Just a reminder that your picture Kucha slides need to be in by midnight tonight. So please send them through to the email for ANSCON. So for our next session, I would like to hand over to Leonardo, who is the University of Canterbury Student Branch Sponsorship Coordinator.
Thank you, Teresa. So today I have the pleasure of introducing you to the Executive Dean, of Engineering of my university, the University of Canterbury. So before I introduce him to the scene, to give you a quick overview, Professor Sab Sinha is a Professor and Executive Dean of Engineering at the University of Canterbury here in New Zealand. Among his many achievements, Professor Sinha is a Fellow of the IEEE, recipient of the prestigious US Fulbright Grant, and has formerly served as IEEE Board of Director and Vice President. Today, he will be providing us an overview of IEEE's organizational structure and explore how the structure could further enhance resources for IEEE student branches. Please give a warm welcome to Professor Sinha.
Good afternoon, everyone. I know it's been a busy period for you. I was just listening to the request around the slides at midnight, and I did notice that there was no time zone specified. I don't know what I mean by that. Sure you do. So firstly, just wanted to say thanks again to Leonardo and the team. About 1 p.m. this afternoon, I got a message from Leonardo, and he said, he said, could you please send us your slides? Put me under quite a bit of pressure, because I didn't have slides counting on points of power and not PowerPoint. So anyway, especially given the kind of work that you folks have been doing the last hour and a half, which says 6 minutes, 6.5 minutes. Oh, you want me to? Oh, for the recording, not for the. Yeah. So. Okay. And so the idea was to then anyway, so I kind of got some slides together, which I thought was anyway, I hope will be useful as a reference for you in future. If you do want to download the slide deck, feel free to just use the QR code, and there's also a link at the bottom that you can use. Have you been able to get the slides with the QR? Did it work for you? Anyone tried it? You are the first recipients of whether it works or not. So, okay. So just moving on to the next slide. In case you do want to record or do some text, I'm quite okay with that. So, if you need speaker's permission or so, feel free to do that. What I'll be covering here is a little bit of history of the IEEE, making it a bit relevant also to your own context from a resourcing perspective, ultimately. And I suspect that some of you may have had this question earlier, as you've had the earlier presenters. So 1884, any idea what was the major invention that came up at that time? So what was it? Power, yes, indeed. That's true. It was electricity that came about in 1884. And there was a gathering that came together in 1884 that said, well, we've got a major invention here in the US in the Philadelphia area, and can we actually get together and can we get sponsors for it? And that's actually how the original organization, the AIEE, the American Institute of Electrical Engineers, came about. The organization then continued to develop its proceedings and its peer-reviewed work, but that was only about close to 10, 12 years after. Peer review was not a big thing at that time. It was really started initially from industry, for industry. The academic component got added later. And so then the organization continued to progress in the electrical, kind of the heavy current side of it, the power side of it. And then in 1912, something happened. Anyone remember a movie with big ship that didn't do very well? The Titanic. And how did the Titanic find some rescue? there was the SOS, right? And so there was the first radio communications that took place there. And so it was around about 1912 that the Institute for Radio Engineers came about. And so the Institute of Radio Engineers and the American Institute of Electrical Engineers then continued to develop side by side. And you can always therefore appreciate that both in the original organization, 1884, and Electrical Connection, light has provided a lot to humanity, and as radios, and initially with the Titanic as one example. And these two aspects then these two areas of heavy and light current of electrical engineering disciplines then continued to progress for many years until people started to see that there was a common electron bind to these areas. And towards, especially after the Second World War, when the transistor came about. So just for some timelines, 1884 was the second industrial revolution, which had the power of electricity. And next revolution was starting to take place in the late 1940s with the transistor coming about. Nobody really called it the third industrial revolution at that time. That came about much later in the early 80s. But that was really the transition that was taking place. And it was quite incredible that when that transistor came about with that electron foundation too, that people still said that let's have heavy current, the American Institute separate and the Institute for Radio Engineers separately. But there were discussions that were taking place that communities, when they were gathering together, they were finding each other's company. And when that company and people were coming together, they actually said, well, perhaps we ought to merge into one organization. So those conversations started to happen. In 1963, the 1st of January, the organization IEEE came to being. It was the Institute of Electrical and Electronic Engineers, and then it continued to progress into various disciplines. But some odd things were taking place then too, because people said that, well, the wars are over, so do we still need technology? That's quite an odd question, isn't it? By the way, universities here in engineering also experienced similar questions post that period. And you will notice that there were changes. If you do look at student numbers, there were actually some changes because, well, the big need is over. Well, incidentally, many of the IEEE technical societies started to come about because of the connection, not only between war and technology, but because of the connection between technology and other technological innovations that enable humanity. By the way, in that mix, the microwave came too, but it only became much relevant to what you find in the kitchen much later because it was too early for its time. So I'm kind of showing that these were some of the dimensions that were coming about in the journey of IEEE to where we are now, 140 years later. And a lot of the technical societies actually emerged in the 70s. Of course, there were the earlier organizations such as Power and Energy Society, which was the power society that came into being right when power came about. So those are some of the older. Communications was another very old society. So those are some of the dimensions that came about. I mentioned these because these will then come later when we talk a bit more about the structure. So that's really the kind of the summary of this. So today, IEEE actually spans multiple disciplines. And if you look at the IEEE designated fields of interest, you will actually notice that it is open to legal professions, it's open to doctors, medical doctors, and it's open to multiple different disciplines where there is an intersection with technology. So if you actually look at the IEEE designated fields of interest, and as an organization, the area of life sciences, and if you look at papers on IEEE Explore, you'd actually find many that relate with the life sciences with medical doctors involved. So as a colloquial memory, I have started to think about the IEEE as an institute of engineers and everybody else. So if you do come from another discipline, don't feel too bad. You are part and certainly very included. As long as you're also looking at advancing technology for humanity, which has been the key tagline since 2010. The IEEE had 200,000 members, primarily in the United States, with 6 regions, regions 1 to 6 in the US, region 7, Canada, and region 9, South America. Region 8 is the blue region, Africa, Middle East, and Europe. Region 10 is where we are. In 2028, region 11 will come about, and region 11 will be Australia and New Zealand. So that's kind of the transitions that one sees. The membership today is 460,000 members, of which 50%, over 50%, are now outside the United States. And so that's been quite a change. And so, oh, look at that. My slides just skipped. Maybe that's a sign. It's more than 20 seconds. So in its organization, and this is probably an interesting thing. So you see all this stuff in the color, the world in the color is actually a part of IEEE that does this organization is called the Member and Geographic Activities Board, or MGA. And we, as you know, most of you are from student branches. Our student branches and sections belong to the governance of Member and Geographic Activities Board. But guess what? I'm actually not going to talk so much about the MGA side of it because you know it. Many of you will know it, and if you don't know it, you'll get familiar with it. It's simply a structure of the org. I'll actually be focusing on other boards of the IEEE, and I'll go more into practical things very quickly. The Technical Activities Board, the Educational Activities Board, and the Humanitarian Technologies Board. And I particularly highlight them as their resourcing that comes from these orgs is significantly more than the member side of things. And I present here the financial report of IEEE. And the last year's financial report would indicate that of $550 million, which is the annual kind of transaction, the member component of IEEE 460,000 members around the world is actually only 10% of this. So the rest of the kind of the revenue of IEEE comes from sale of periodicals or proceedings. If you look for a paper on your university site and you very quickly access it, that's because the university pays a subscription fee to IEEE, and around the world there are many others. There are 1,300 conferences that take place each year, and the conference and proceeding and revenue from publications actually is the bulk of the revenue of IEEE. Now, guess what happens? That particular revenue source does not go to the Member and Geographic Activities Board. It actually goes to the Technical Activities Board, and it goes to the Publication Services and Products Board. Now, you would therefore appreciate that if we and you align yourself, there's no harm in aligning yourself with good resources, is it? You wouldn't be opposed to it, would you? So the key thing is, how do we actually align ourselves better with the technical activities and therefore be able to access greater resourcing for your activities? So the IEEE is then organized in technical societies. Here today, you have Yong Fu at the back, who's going to be talking next, just after me. He is from the Circuits and Systems Society, and similarly, there's microwave theory, there's power and energy, there's communications, there's a whole range. In fact, until the end of last year, there are 39 societies, and there were 6 councils. Now there's a 7th council, which is the Electrification Council, which was induced at the beginning of this year. And so sometimes societies move into being technical council. The main difference is that societies have members who are individual, and councils have members which are societies. So that's in the technical society. So for example, nanotechnology is a council which deals with a couple of technical societies like electron devices, circuits and systems, and others. So that's really the difference between the one was geographical organization and the other is the technical organization. And if you think back into your own academic school, your own academic department, you would find, and some of you are graduate students, and you would find that you have you might be working in the area of control and automation, you might be working in robotics, you might be working in signal processing. So as you're looking at this list, you might have a technical interest, which might be in bioengineering. And as you are looking at this list, you're probably saying, maybe there are these 2 or 3 areas that's of interest to me. And if you are, that's good, because that actually is likely to be your home within a home. It's like when you're in a home, there's always a room which is more comfortable than another. And that's a little bit like what happens with the societies and council. So then just moving to the next slide. So I'll give an example. In my background, I actually didn't mention that I'm from South Africa. And so you will notice some 1 or 2 examples from there. I've only been here for a year. So some of my examples still do struggle on other continents. So each of these societies lends to the potential of creating a student branch technical chapter. Noting that a number of you are student branch leaders, does your student branch have a technical society chapter? Anyone? You should have some. No? No? Not? No? Yes, you do. Which one do you have? You have PES? Yeah. 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 So the PES is a great example. PES has many, many chapters around the world. And so that's a good example. And hopefully that, if people want to talk about how you initiated it, or how what kind of activities take place to sustain it, you'd have some advice. So I want to give an example from the University of Pretoria, which you could put in University of X there, is that the university's electrical engineering department was organized with a couple of research groups, and the research groups developed alignment with a cluster of technical society chapters. And once that was there, then they developed student-run chapters, and the student-run chapters often had a counselor or a student-run chapter advisor, which used to sometimes could be a postdoctoral fellow, could be a faculty advisor, permanent staff member as well. And so there was different groups. And so with the support of that advisor, there would then be a student-run chapter. So in case you have not created a student-run chapter, the process is actually quite simple. It's to create, you just need 6 student members that belong to that particular technical chapter. I know that Jongfu will have a very special announcement about the CAS subscriptions. So I will allow you to have his presentation in anticipation and not reveal that at this point. So creating it's quite easy. Just there's a petition link. And the key thing always with these student-run chapters is to keep in mind that it's not only about initiating the chapter, it's about ensuring that the chapter is sustained. And that sometimes can be challenging because students often graduate, which is great. And that means that continuity sometimes breaks. So almost as you come in, it's a good idea to start recruiting who will be the successor, which is a nice skill to have, as when you're in industry or in other places, you find that that's a valuable, thing to think about. Activities inviting, PhD students often who initiate chapters get quite a bit of benefits because you have the potential to invite distinguished lecturers. Often distinguished lecturers of technical societies are associate editors, editors of IEEE journals. And if you are publishing in IEEE journals, you will often find that, peer review can be a very tough process. Has anyone been through a tough peer review process? You have, so you know that there's always that reviewer too that gives you a hard time. And so if you're working within, if you're inviting distinguished lecturers, so often you will get insights. So for example, a distinguished lecturer who is an associate editor might tell you that there's a special call for an issue. Would you like to be involved as a reviewer? Oh, that's pretty cool, because then you can start to understand how the review process works, and that gives you an advantage. And you can initiate projects. So I'll give some examples of projects. And it is the activities that make the life of the chapter interesting. And it is then in the activities that you find that chapters sustain. I'm going to just give some examples of activities before moving into a separate part of the org. And so this is just an example of the ITSS, which is the Intelligent Transportation System Society. And I selected this particularly because Isha is here. Where is Isha? People are closer. Isha is from UC's Motor Club. And so that's the formula vehicle that's UC. And they also deal with electric vehicles. And I know that often almost all the unis in Australia and New Zealand have something that's there. And so ITSS, this is just an example of a proposal that came about last December. And if you have a ITSS student-run chapter, you have the potential to tap onto that particular resource. Now, I know many student branches get $100 or so if you have a student branch. And sometimes if you have it affiliated with a uni, then you'll probably get some more from the uni. But this is an example of what are the numbers that you're looking at when you make a proposal here. And you will notice it tells you that don't have proposals that are too expensive, and each proposal should not be more than $4,000. And so you can very quickly see that the magnitude of resourcing changes the moment you work with technical societies. And that makes sense if you think about that financial annual report where 10% is membership and the rest is from other sources. This is what happens with the remainder of the resources. It all gets redistributed to people. So this is an example from ITSS. And if you're in the robotics area, you can look at it. Circuits and Systems have their own initiative. And in this case, there are 10 initiatives. And I can tell you that sometimes there are not enough proposals that come, particularly from Austin, New Zealand. And so if you do make submissions, then you have chance of acceptance is pretty high. So each of the societies would have similar examples. So I'm going to move on to another segment of the IEEE. And this has to do with the tagline. So up until 2010, IEEE tagline was networking well, which was a prominent tagline. I think it came about in the late 90s, and it stuck up until 2010. 2008, an initiative was coming up, was the linkage between technology and humanitarian activities. And the quest was that technology should not be for the development of just technology, but technology should have an outward looking and an approach that is enabling to society. And that's where this tagline came about. When the tagline was adopted, Feb 2010, it was envisaged that there will be projects and programs that would be funded that would support the particular tagline. And that's so there are a huge range of, so that the other boards, the Educational Activities Board, the Humanitarian Technologies Board, they then got funding allocation. Humanitarian Technologies received $1 million from IEEE to distribute in projects around the world. And Educational Activities received a similar figure. And Try Engineering is a portal. Try Engineering picked up a lot of, received a lot of interest, particularly in the United States, as many pre-university students were not looking at doing electrical engineering programs. In fact, there was a decline in the number of students that would pick up electrical engineering. It's a bit different to this part of the world, where if you look at the number of pre-university students that are looking to, when they're leaving school, 1 in 2 will take, at least in New Zealand, I don't know the figures of Australia, but in New Zealand, 1 in 2 will take an interest in doing engineering, which is amazing, by the way. That's really, really high. But anyway, so Try Engineering is another example that if you are interested in working in the pre-university groups, then that's an initiative which is granted. Another initiative is the Engineering Projects in Community Service initiative. This came out of Purdue University. Purdue initiated this in the mid-90s, and IEEE adopted this in 2009. And I'm kind of very pleased to see this initiative because Kapil Dandekar and I are the co-founders of this initiative for IEEE as a global organization. EPICS is an initiative where non-governmental organizations together with pre-university identify a problem that the community faces. So an example of a problem might be air quality. It could be relating to the environment. It could be relating to any other activity that you see that society is grappling with and can solve with technology. But it's always an initiative that is with the community. It's not to the community. It's not for the community. It takes community parameters at the outset in how the parameters are designed. Lots of calls there here. There's a call existing right now, which is the AI and autonomous systems in service learning. And if you're interested, you can take a look at the website and see how the call. Has anyone applied and received an EPICS grant in the past? Yeah, that's here. No? So that's a very good sign. And I did look at the data. So I did see that there were not many EPICS applications from this part of the world. So at the moment, EPICS is in about 50 countries. And Australia and New Zealand certainly can have applications developed. Oh, by the way, the other nice thing about the EPICS initiative is that you can actually have peer-reviewed papers that often come out of these areas. The other board that was introduced was the Humanitarian Technologies Board. And here the interest was that if you look at the Sustainable Development Goals of the United Nations, which came about 2013, September 2013, I think, the Sustainable Development Goals include, for example, Goal 9 is the goal on innovation, infrastructure, and industry. And if you align with one of the UN SDGs, then you can develop an application. Application grant ranges typically $10,000 and above. That's the range. The EPICS range, it's usually between $2,000 to $5,000, but it can be more. We have funded in EPICS up to $25,000 as well. And it all depends on the networks. The humanitarian activities actually came later, and at the moment, Luanga, who is from Uganda, is the global chair of this particular board. Another area that might be of interest is the IEEE Foundation. And I know, for instance, Canterbury is organizing TenCon next year. And if they're members of TenCon on here, I think they are a couple, then IEEE Foundation is one. So IEEE Foundation is a separate organization to the IEEE, but it works quite closely together. It's also incorporated separately. And here you can also develop proposals. Organizational aspects also get funded, and student activities are greatly supported. A major source of revenue for IEEE Foundation, or donations of IEEE Foundation, is the IEEE Life members. And so that's a very important input into the funding. And often what happens is, so for example, the societies of IEEE will often be making a surplus, but IEEE is a non-profit organization. But because the societies sometimes end up making so much surplus that there becomes a risk to the organization that it might not get classified as a non-profit organization. So what then happens is that the societies will move some of their funding into the foundation so that that money can also be distributed to member activities. But the advantage of moving it into the IEEE Foundation is that the foundation can then say, hey, we've got some funding coming in, say from circuits and systems. Can we get a matching funding from another external donor, external to the IEEE? And that then leads to that funding becoming bigger. And a very good example is the Power and Energy Society that created the PES scholarships. And a lot of that was through matching funding. And by the way, it's not very different to how universities would work. So you would notice that a lot of the universities where you're part of has a foundation. And that's what foundations would do. So that's very similar to how the IEEE Foundation came about. So the IEEE Foundation link for finding and requesting funding is a little hidden. It's right at the bottom of the page. So if you are on the IEEE Foundation page, keep scrolling. Or you can just click this particular link when you need to get it. Another area is women in engineering. Women in engineering is within the MGA cluster, but I thought I will mention this because there is funding, particularly travel funding that's there. And there are a number of scholarships as well. And you can have an affinity group, like you can have a technical chapter for women in engineering. Are there groups here that have women in engineering affinity groups? New Zealand North has, yeah. And I think that I was told that the Canterbury Women in Engineering started through the IEEE, but then became an organization of its own. So it's quite possible that there are initiatives, but there is some grants available here as well. So a possible opportunity for you to think about is to think about having a student branch technical chapter and see what linkages it develops. And I should say that in the beginning, it feels like a little bit of work in being involved. And I'll tell you with my own experience, I became involved as a student member in the 90s, and I got very involved actually in the circuits and systems and microwave theory area. And, you know, and the group really continued to support me through my academic career. You know, there was a special issue of a journal coming about that reach out and say, hey, Sarah, would you like to assist in this? Can you do some editorial work here? Can you do some review and things like that? When you go for things like, you know, being a fellow, you need a huge congregation of referees from all over the world. It's really a complex process, but it's not so complex if you've got great peers within the society. That's often a very key element. And so I definitely think that investing time, whether you're in industry, whether you're in academia, with the technical societies is something quite worthwhile. And similarly with Affinity Group, and you've seen the array of the humanitarian activity technologies projects. So that's really what I wanted to cover for this session. And of course that, you know, there is a lot of innovation that takes place, and it takes place because of our community here, but also around the world and our connectedness. And I'm sure you will find, if not now, but in the near future, that I think Leonardo and I often talk that whenever you go almost anywhere in the world with the IEEE's presence in over 190 countries, that's about the world, by the way, that it's actually not impossible to find a friend in these places. Really worthwhile. When I moved over from South Africa to New Zealand, some of the first people I contacted were IEEE members, and I obviously had the community that the university had to offer. Then there were folks in New Zealand South section that I connected with initially, and then I came over here to Auckland, met with Nirmal and others. And so it's really a very worthwhile journey that one gets. It is a little bit like a gym. If you're not going there, you know, gyms make money off people who don't go there. So it's very similar to this. The more active you are within the organization, the greater is your return to it. I think that's probably the biggest benefit of being a member and being active, particularly in technical societies. So with that, I will pause. I know I have exceeded the time a bit, but I want to see if there's any questions. Otherwise, we could also take questions together once Yongfu has presented, because I just... Are we in the tea break? Sorry, guys. Okay. So are there any questions, any ideas, any thoughts that you may have? I couldn't have been that clear. Or you might have been very tired. Any ideas? Yeah.
What happened? Why you have many societies?
Yeah. Yeah, I think you can just, if they're in existence, you can just organize to have joint activities, but doing things together is always a great approach.
The number of students limit. They have too many slides.
Yeah. Yes, it can get complicated if your numbers grow, but that's a good problem to have. That's a good problem to have. If you are experiencing that, that's great. Well done. I think that having the activities, look, you can also have joint, you can also have the chapters to be joint, but there are pros and cons to it. And Yongfu will tell you that if you have electron devices, for example, and circuits and systems as a joint chapter, which is a configuration that makes sense technically often. But when you apply for, say, an outreach grant to the Circuits and Systems Society, they look at the submission, they're like, oh, this is great, but he's got a joint chapter. Maybe they need to go and ask EDS first. You get a bit of that. So sometimes if you have EDS and you have CAS and you have a big event coming up and you have a big budget, you've got two proposals that go to the two acknowledging the other, or you have two different events that are supported by, one is supported by EDS, the other one is supported by CAS. So something like that. So I think you should, if that's the case, you should get together, synergize, and say, well, you know, the IRE and AIEE could do it. They had just about 100,000 members at that time. So our problem should probably not be that big. And of course, today with technology, it just changes with AI and LLMs. The way that you do organization and coordination just changes altogether. Yep. Leonardo?
So we have now, I think, 3 student scientists from New Zealand and maybe 3 or 2 from Australia here, student branches. Would you have any recommendations for us to how to collaborate between Australia and New Zealand and the student branches?
Yeah, I think that events such as TenCon that are coming up and creates the opportunity for in-person engagements, I think is good. I do know that some students may have difficulties with travel, so you can make an application to IEEE Foundation. I should say I do have a conflict of interest there since I serve on the funding committee, but I will recuse myself and do all good things and still support you somehow. So I think that's one avenue. The other avenue is actually to do projects jointly together. So you could look at, I'll give you an example of an EPICS project that I hosted in Pretoria, and I had the twin program of that was in Philadelphia in the United States. And the project in South Africa was to use, the problem that we were solving was that the law changed in terms of air quality measurements. And the thresholds were much more defined due to the mining activity that takes place there. And that meant that the kind of sensing that took place at the macro level was now suddenly insufficient. And so a more refined measurement system was required. Almost think about like having your mobile phones. And if your mobile phones could have a device that you could just insert and it could measure air quality, something like that. And that was very similar to what one of our colleagues were talking about yesterday. And so something like that was then the project that was taking place in Pretoria. In Philadelphia, the project was exactly the same, but it was to measure, you know, from an environmental, a different perspective. And they essentially had sensors distributed along more or less every lamppost. And then they were compared, the results were compared, students collaborated across different time zones. And they actually wrote a technical paper at the end of that process. And so that's an example of, so I think where you have project-based, you know, approach, which allows you to do things in one's own time zone, but then also come together, then that I think is one approach. Any further questions? Okay, if not, I'll be around during the tea, coffee break until late. Yeah. Yeah, of course.